Good morning, or good afternoon, or good evening. It's a little belated, but let me wish you all a happy new year. My name is Andrea Zenz, and I'm one of the product managers here at Standard Imaging. I welcome you and thank you for attending our webinar series. Just a note before we get into today's topic, this webinar is being recorded and will be available on our website shortly. Attendees are in listen-only mode, but you are encouraged to type questions you might have into the question box on your webinar console, and I will try to get to those at the end of the talk. And a brief introduction for myself and for our company. Standard Imaging is based in Middleton, Wisconsin, and was founded in 1989. From our humble beginnings of well chambers and electrometers, we have grown into a QA powerhouse where we design and manufacture a full suite of QA products for radiation therapy. Customers are our partners in ensuring that radiation treatments are as safe, efficient, and effective as possible. It is an absolute pleasure to work with you now and in the future to solve your QA challenges. And as for me, I've been with Standard Imaging for over 16, maybe even 17 years at this point, in a variety of roles in sales and now in product management. My product portfolio includes our brachytherapy solutions, QA Stereo Checker for filmless CyberKnife and Linac machine QA, QA Pilot, our physics QA management software, and our Stereotactic Phantoms, which of course is our focus for today's webinar. So of course, we're going to be talking here about specialized Stereotactic QA Solutions, which for us means our Lucy 3D QA Phantom and our Stereotactic Dose Verification Phantom. So what are the goals of a safe and effective Stereotactic QA program? It's a great question and an important one. After all, delivering just a few fractions at high dose rates can be daunting. Precision and accuracy in QA are of the utmost concern as you care for your patients, so the products that provide you with the QA should be chosen carefully. Stereotactic QA goals include positional accuracy, dose accuracy, and validation of imaging, planning, and treatment systems. Stereotactic programs don't usually start with treating complex multiple metastases in the brain, but with larger tumors in other organs, typically lung. The SI solution to get you started with SBRT includes a Stereotactic Dose Verification Phantom, SDVP for short, with a QA slab and lung materials, the Respiratory Gating Platform, or RGP for short, which is a simplified platform that independently controls the range of motion and the respiratory cycle. A Winston-Lutz pointer is, of course, hugely important. And I would highly recommend our Supermax electrometer as a powerhouse electrometer, very reliable device that offers a lot of functionality. No solution can, of course, be called complete without detectors. So two of the best detectors for verifying small field delivery are the W2 scintillator here on the left with the Max SD, and of course our X-Radon A26 micropoint chamber. The W2 is the next generation of our W1 scintillator, which can also be used, of course. The W2 has a 1x1 millimeter fiber, whereas the W1 has a 1x3 millimeter fiber, but both have a KQ of 1, making either, but most people with the prefer the 1x1 millimeter. Our scintillators are the premier measurement detector for the smallest fields. The X-Radon A26 is made entirely of low Z materials, which make it the only reference class micropoint chamber on the market without some of the, and here's my ever so sophisticated terminology, wonky effects that other micropoint chambers currently offer. So using the 826 is as predictable, gives you as predictable a response curve for those small fields as you would get using a farmer chamber in a larger field. The SDVP, as I mentioned earlier, is in fact a very versatile and compact phantom, being a 20 by 20 cm stack. As you see here, there are at least 4 standard configurations. There are embedded fiducials within the phantom configured to be nonlinear, non-coplanar to create an isocentric volume. Our chamber plug with gold markers is useful for localization and fiducial tracking of smaller tumors. The QA slab includes, which you can see here a little bit, includes a variety of materials in order to spot check your CT densities. It has air, water, adipose, fat, trabecular, and cortical bone. It also includes high contrast target and avoidance structures to test TPS reconstruction capabilities. The stereotactic dose verification phantom heterogeneity lung inserts, which are comprised of 3 slabs here, facilitate the calculation for Monte Carlo type calculations, something otherwise found only in much more expensive phantoms. The Lucy Phantom is the gold standard used for end-to-end testing of the entire stereotactic treatment chain. The precision manufacturing of this phantom allows the user to verify cumulative uncertainties along the treatment chain to within 0.1 millimeter accuracy. This is accomplished by using a variety of inserts with precisely known volumes, geometries, and distances for accurate measurement. We work with each customer to tailor the best Lucy package to your department's particular needs. Lucy is uniquely designed to lock the phantom and inserts in place to facilitate reproducible setup and measurement to these very tight tolerances. Lucy is put through the same processes as an actual patient, which means that the phantom will be scanned on CT and or MRI to start that treatment chain. It is therefore very important to perform a variety of QA tests on these imaging systems. For CT image QA, we have marker cylinders, irregular volume inserts, the CT densities, same as with our stereotactic dose verification phantom, spot check of adipose, fat, trabecular, cortical bone, air, and the blue is water equivalent. And also we have the distortion grid. CT scan tests may include various scan thicknesses to find the optimal thickness for SRS imaging, spacing, distortion, and phantom orientation. MRI inserts include matching marker cylinders, which in the case for MRI are mineral oil filled. We also have isocentric irregular volume insert and our 3 isocentric irregular volume, or 3 irregular volumes that match those of the seen on the CT inserts. The irregular volume insert can be used, of course, on CT and MR. The marker cylinders, both with CT and MRI, have a known distance of 5 millimeters center BB to center BB, and they're placed in the phantom at 60 millimeters apart from center cylinder to center cylinder. The irregular volume inserts, of course, we have the known volume of these, which you are testing against. The CT and MR inserts are used to perform image fusion and verify accuracy of multimodality fusion, such as CT to CT, CT to MR, verify object reconstruction, compare scanned object volume against known volume, verify position of objects, those centroids and BBs, and distance measurements. It is worth noting that we use irregular volumes instead of just circles or spheres, as this is the quickest way to see any issues in image fusion. After all, an arc on a circle is just an arc on a circle. For treatment plan system QA, you can test the following: organ volumes, manual versus auto segmentation, contoured volume versus a standard volume, or versus DVH isodose volumes, dose models such as Monte Carlo, conventional, and pencil beam, and the TPS limitations for small fields and accessory couch modeling. The left here is a plan image to deliver 4 conformal arcs on an isocentric irregular target, and the right demonstrates a plan on our largest volume of the irregular volume insert. Verification of the treatment is done using film and micropoint ion chambers and/or other small detectors, as I already mentioned earlier. Note that the detector insert is 1 cm thick. Therefore, detectors you use need to have an outer diameter of less than 1 centimeter. Again, our X-ray Na26 and W2 scintillator are both ideal solutions for point measurements. One of the unique aspects of our Phantom is that we lock in the detector in place so that you never have to worry about an air gap or chamber displacement. The centroid of the collecting volume will be locked at the geometric center of the Lucy Phantom, no matter the orientation or rotation. The Lucy 3D Volumetric Target Dosimetry Kit, which consists of all these items shown here, include on the left our multi-METS target. On the right, you have the film inserts, which will place, and spacers, which will place film across the center of these targets in the multi-METS insert. You also here in the center have our target and avoidance structure. This is similar, well, in fact, same build as we put in our stereotactic dose verification Phantom. Again, the black is high density contrast material against a water equivalent material to really test your treatment planning system ability to create, to recreate these shapes. And for testing contouring volume accuracy, image transfer accuracy, and the limitation of dose algorithms. You can therefore go through the entire workflow with these inserts as a great end-to-end test. Here we have an image of a Z-shaped target planned for delivery, which is then verified with film and micropoint detector. The multi-METS insert has 4 targets in nonlinear, non-coplanar arrangements. These, plus the hidden target insert, which comes with the Phantom, provides 5 targets for planning and treatment. In this case, we show a plan for 2 targets using the multi-METS insert. The planned versus measured QA results were found to have the pass rate of 2%, 2 millimeters, with a dose agreement of greater than 98%. Other end-to-end tests with Lucy include a hidden target test using the insert with a central fiducial. Again, we provide a hidden Winston-Lutz target with the Phantom. You can use this plan to plan, scan, treat, and verify the process QA checking position, tolerance to within under a millimeter, a dose tolerance under 2%, a dose distribution, usually using tolerances of 2%, 2 millimeter, and a greater than 95% agreement. Mechanical accuracy is tested with the Winston-Lutz pointer, which you see here on the left. You can, of course, use a hidden Winston-Lutz, but a lot of people like a pointer separate from that within the spherical Lucy head. And then, of course, we have our pipspro stereotactic module, which will automate the analysis of those images captured with your EPID for the Winston-Lutz test. To summarize, whether you use Lucy on its standard precision base locked to a couch bar, or you lock the phantom or the pointer into isocentric coordinate system of your system with an interface, or you want to ensure that the centroid of your detector's collecting volume is at isocenter, you can be confident that you are performing your SRS end-to-end QA with the best precision and accuracy. I have focused the greatest part of this presentation on our hardware side of the standard imaging SRS solution, but it probably leaves you wondering about patient QA. Again, few fractions delivered at high dose rates require the most rigorous QA. So let me mention our patient QA solutions. I'm not the product manager for them, but I can at least introduce them to you. These provide the most pertinent information automatically for your team to make treatment decisions. Firstly, Adaptivo, which includes pre-treatment, in vivo, and adaptive modules. Adaptivo gives you full insight into your patient's treatment at each fraction, improving your ability to adapt plans as needed. The software not only automates pre-treatment and exit dose delivery verification, but also uses the daily CBCT to provide automatic daily and cumulative 3D dose comparison to intended dose. Linac View is Standard Imaging's log file-based patient QA solution. An overview of the workflow is shown here. An approved plan is exported to both the Linac, including Elekta's MR-Linac Unity, and Linac View. Once Linac View has received the RT plan, the log files that are generated from each delivery of this plan will automatically be brought into Linac View, associated with the original RT plan, and analyzed. Not only does Linac View provide pass-fail, alert, and fail results before a patient leaves the table, it also provides a wealth of information to investigate, understand, and address any issues with the patient treatment. That brings me to the end of today's presentation. So I will give you a moment to type in any questions that you may have about our stereotactic solutions. And while you're doing that, I would just like to remind everyone that we have a wealth of information about our products and services on our website. Should you think of any questions once today's session has ended, please feel free to reach out, contact either sales@standardimaging.com, or you can email me directly at azens@standardimaging.com to get those questions answered. I'd also like to take a moment to let you know what we're queuing up, that we are queuing up a lot of great content for 2022. We have had a phenomenal response to our podcast that we started last year, Out of the Gray. Needless to say, we have a great lineup of guests already for 2022, and that will continue to broadcast on a weekly basis. We will also be starting a new clinical experience webinar series coming soon. I don't have exact dates yet, but it will be coming soon. So you'll want to be sure to check out our website for the upcoming webinars, or of course you can watch any webinars that you may have missed. Now let me go over here and double check to see whether there are any questions. And I am not seeing anything there. So with that, I will say thank you ever so much for attending our webinar today. I wish you the very best rest of the day and a fantastic 2022. I'll be talking to you next month, if not sooner. Bye-bye.